Alright, since that was an hour long and you guys suck for constantly asking questions, and apparently you didn't know everything I knew, but you said things wouldn't work, but then you realized they do work. And then I would hope apologizing would help that out, most likely. You know, me, I'm a mean bastard and a half. Like, for what it's worth, I don't deal with people not knowing things well. Like, you're a stupid dumbass trying to pretend to be some PhD or works in this field or something else, and you don't think that this will work. Well, here's why you're wrong and incorrect. And it's like, so many engineers and more will probably understand that, because it's like, am I getting a PhD thesis examination, defending things, or, some other shit? It's like, this is stupid. No, this is my own concept and design. You can go fuck right off. Get out of here. Get out of here, you dang knobs. Look, man. Look. I would just, I can't picture how this would work because I have a PhD and I work in the freaking, field, but, I can't figure it out. And everything in my brain go burr really hard when you start talking about it. I'm like, okay, fine. Let me talk you through the process as my GED dropped out of college, community college, ass is ultimately doing. Just so you know. It's like, no, I don't. That's not fair. Look, man, I'm smart too. I'm sure you are. I get it, not to be mean. But it's like, if you're going to be mean to me and you're going to treat me like that, expect it coming back just as hard. Get out of here, you. So, that's where I'm at on that. It doesn't really make much sense after a certain point. Anyways, little ASMR of water for you. It's going to make a degree of change. Maybe vaporization will occur. I know, it's like, why do you need to do this thing where you use the vaporization of the material, the hydraulic fluid, to press onto the blades? And it's like, oh, right, yeah, well, for what it's worth, it's just more efficient at, changing the degree of, captured too hot vaporized hydraulic fluid. So it's going to get quite hot. Turbines all get very hot, and, for what it's worth, you kind of want the heat. You don't really want to remove heat, And so, it's a catch-22. It's like, well, I'm going to take in air, and then I'm going to compress it, massively. I want to really compress this stuff. But hydrogen doesn't deal with that very well when it's around air. And if it's really fairly cold, it'll still do it fairly well up to a point of PSI. And then after that, it'll just detonate. So, it's like, that's kind of where I'm at in terms of limits. You know what I mean? And so, as it bubbles and wicks away, because it's going to heat up inside the engine block, and that's going to bubble away. And then that produces its own version of a thermal siphon. As, colder is in the center, and it'll produce a lower pressure effect at the top, and then that's going to get wicked away into the, version of a thermocouple designed radiator. So it's like the radiator's gets hot enough, thermocouples, it then has a pressurized valve, like a blow-off valve. That it's it has to hit a certain pressure, so it fires off into the radiator, and then has a larger opening, like I was saying in the shower concept design, that goes into, from a larger, with all those little, vapor chamber heat sinks that are inside of that, to a smaller design of tube, meaning size. still with the heat sinks that are in on the inside and on the outside to improve its thermal conductivity and ultimately its rapid decrease of heat for the radiator design. Because it's now a vapor, and when it compresses, because it's cooling, meaning condensing, which is still compressing, because if you didn't know, you're stupid if you think that's not basically the same thing to me. You know what I mean? Like, I don't see it as different. It makes no sense. It is basically the same. I am condensing this fucking fluid into a smaller, denser fluid. And I just took heat away. Isn't that compression? What if I put it under immense amounts of pressure? Would it then do the... Yes, it would. Wait, who are you? It's like, it seems redundant using two words for the same effect. Just letting you know, it seems rather really stupid. Instant coffee time, folks. Really? I get instant coffee today. I'm slowly trying to remove coffee from my caffeine, really. Well, for a while. I have a fatty liver. I got diagnosed with a fatty liver. That's why my liver enzymes are high. Yeah, the whole ultrasound and everything. But that makes sense considering the amount of sugar I used to eat when I was a kid, and I still kind of eat a lot of sugar for what it's worth. I'm trying to remove it, but every time I try and remove sugar or caffeine, it's like, my entire system is shutting down. Go fuck yourself, don't do anything. I'm also severely ADHD, and Vyvanse does practically nothing. So, it's one of those things where it's like, well, can I just accept this? No, your fatty liver says otherwise. Anyway, but it's compressing, condensing, whatever, right? So it takes heat away, but also it takes it from a larger to a smaller, which is also going to help out with condensing and also its compression. All right, along with fluid flow, because it goes in at a higher pressure and then it's going to cool off and at higher heat too, which uses that pressure in one reservoir and then the smaller amount of pressure in another reservoir to make a version of a thermal siphon pump, which means I have less energy cost to make the whole system work. Goes in from the top and comes out the bottom, which is side reservoirs. They go sideways. They just happen to come out at the bottom because that makes more sense for what it's worth. But the turboprop is different. It uses the engine housing block as its own version of a radiator, as it will bubble out to the outside and then it will cool as air passes around, and then it'll go towards the rear, which is a bunch of stator blades, effectively, which is its own version of, hey, guess what? I have this thing called a radiator now, heat sink combo, that's in the rear, which is just before where the exhaust is going to come out. So it's like I now have an increased surface area, which means I now can cool the darn thing at the higher altitudes without having the inefficiency losses from creep. So that's why I do that. Makes it a lot easier for me to gain efficiency advantages. And that's also why I made like a really small version, because it was meant for motorcycle. Like the turbine was meant for a motorcycle. For anyone out there, it was meant for a motorcycle. It's meant for a really small bike. Like my bike specifically. I was like, well, for what it's worth, some hydrocarbons and, like a turbine, after, and then I can just kind of dump it off to the one side. I don't need it to be, it's going to be a relatively, small version instead of like the super, larger blades, because that's the inlet. Like the whole engine blocks are quite a bit different. Like they're longer, blades for what it's worth, and they're going to be both from that center point further away. So it's like if we're going to take the housing hub, well, they're going to be further away for these versus for like that, which was like fairly short afterwards. Yeah, and it was just one pack. There's no double packs after that, you know what I mean? It just went from that into the turbine, and then that went off into the side turbine because that made it more efficient in its weight, and, for what it's worth, I don't need extremely large blades on a tiny little bike that certainly can do a lot, but, can't do everything. So, but it was meant for like really high efficiency hydrogen or hydrocarbon use that would capture it in the catalytic conversion process as graphite in a catch can, and then that would allow for me to really reduce the inefficiencies and the pollution of motorcycles, because I was like, well, they're really polluting. Like they're usually two-stroke to, they don't have a lot of catalytic conversion. They're not required, and so like they're fairly pollution heavy. I love them. I never really got to ride on any of them, but I love them. I love the look of them. You know what I mean? So that's what that is. But it was like, right, but I have a bike, and like this would make this definitely, because I can easily hit like tons of torque, like so much. Look at the torque I've got on this bad boy. Dong. Boom. Look at this. It holds so much torque. Look at this torque. The RPM might not be very big, but I don't need it. I have transmission. You know what I mean? And so it turned into like, oh, I could just travel at fucking 70, 80, 100 miles. I just need to hit 100 miles an hour. If I've got 20 horsepower to give you, which is like, I have like 500 horsepower to give you. What did you say there? What was that? It was like 500 horsepower. About 750 foot-pounds of torque. Which then turned into its own, like, design off for a long time for me. It was like, it's gonna kill everyone, so now it's hydraulic fluid turbine styles of gearing with an axle hub in the wheel that has gearing like cone gears, that are like that, which then the shaft moves, but then it's like then there's an outside turbine that goes from out to in for the axle, and then the in slowly pushes, and if it spins fast enough, it'll slip, and it'll have this moment where it catches the next gear. And so that gear then changes the shaft speed, but then also will change its direction, meaning movement forward or rear, and changes dynamically like a CVT its gearing. But I can only put so many gears there. So it's like there's only so many gears on the cone that's there that I can have, and I have to have it like a planetary setup, which then puts it into the outer. Thanks, Phaser. You're so nice to me sometimes. Anyways, that goes into the wheel, and then everything else, and I had it towards the front in the rear, because it's like, well, I can do flexible, extruded, kind of hard rubber hoses, and then the turbine just has like, the front and rear, respectively, turbines, like a torque converter, it pumps it. It's a turbo pump, effectively. You know what I mean? So it's like, well, I can push that on one side out to the axle in the front, and then in the rear, on the rear side to the axle in the rear, which is nice. You kind of want that. It's a good way to do it. And then I have to return it, which is fine, because that's just a return line from the center and then on out a little bit, just a little out. It's basically just going to curve it towards the line, and then like that helps it return back and then goes back into being pressurized and fluid flowed, which is really just faster fluid because it's non-compressible. But then, that's always kind of the weird thing with water. They were like, it's pressurized, it's this many psi's, and like it's a very high pressure, I guess, in a way, but it's really more just really high fluid through a capillary. But whatever. Which those ones are just fullers inside of an extruded, hard rubber plastic kind of style for the hydraulic fluid. So that way the boundary layers are a little less because there's the right dimples and the right fullers. So that way it produces those little, cavitation areas. So that way the fluid on the center flows more than on the outside. And most of it's towards the center. And you reduce boundary layer issues. Now, that one took a while, but it's very, very efficient, and there's a whole bunch more for that turbine from out to end to out, or more specifically, out to end to slightly curved out, through that, because it has to lubricate all those gears and everything, like a transmission and differential and an axle. Yeah, and it's, got some weight to it for what it is. It's got some loss to it for what it is. It's a CVT-ish, not really, but there's a large amount of gearing, up to 42 specifically gears for a bike instead of 7, but I use gear packs. This is the difference. I got rid of the reverse. You have to use your legs. Deal with it. And then I said, you have 7 gear packs. So that means you can have 6 in each one of the gears, but if you play around with it correctly, you get a little bit different, because like you usually want a little easier for the dumpage that people almost inevitably do. From higher RPM to lower, like speeds. It's like, off the line starts, and I don't want you to die. So it's like, well, it's going to slip a little, and it's going to do that, and it's going to move it, and so you're not going to die, and you're not going to just get bucked off your ride, which is nice. And then it's like, I've got some nice overdrive, and then I've got a lot of short shifty gears that are there in the packs, and so they feel like they're really long gears, but like you always seem to have the right amount of torque and the right gear for that given turn or for that given acceleration, which is nice. And they're very robust because they're hyper-eutectic aluminum coated in ceramic, very lightweight. It is very hard ceramic. It has to be thick enough with the right amount of thick hyper-eutectic, which we have to plate effectively. Like we have to stamp it, so there's like dun, 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 boom, 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 and then like we weld it, and then we plate, the ceramic. More in this case, it's casting the ceramic, and then we during that process just with all the electricity stuff that I talk about, and it removes porosity, and it comes out pretty darn near finished. Caveat: we have to get some lasers, and we have to get some or whatever that material is that it's harder, and then it shaves it down to the right specificity of sizing for everything. It's just like it'll be a little bit larger for what it's worth. I tend to do the little bit larger, and then I get it back into the right area, slightly technically above. We're talking less than microns. So that way, during his rubbing in with the fluid break-in area, then you can change that fluid out, and then it's like definitely just right. It's like it's good to go. You know what I mean? Which I like that. It's that's what it was. But then they were like, I don't want the front, and I was like, I have a really cool setup for our tail with a wrist pin. So it's a soft tail with a wrist pin where the axle is, because I need the axle to not move as much. And if it moves a lot, like it'll get slop introduced and grinding, and I don't want any of that. So I was like, if I get a little bit of a wrist pin while it moves and it bumps with the soft tail, think like a fishtail when it's on the side. Like the body moves, and then the tail can move as well. That kind of thing. So it's kind of like that in the rear. So it moves a little bit more. What that does is it introduces a greater degree of, you know, resistance to the bumps and comfort for you, because it's the right springs and shocks that are going to be there in the supportive material in that tail instead of just a straight triangle. You have to have the right arcs. So we have a triangular arc. Think like a circle, and then we put an arc that's flat, that's trying to be the 90-degree part, and then like an arc, you know, that's to the point where the wrist pin is, which is a circle, which then has an arc in the 90-degree, which is where you connect your spring and shock, both on the front and the rear. And that allows for it to bend a little bit more, you know, and it's able to handle forces of going from side to side, high camber basically, and up and down rapidly. Alright, that's also why the lines are hard rubber plastic combos that are extruded. That increases the degree of motion resistance, meaning it won't pop off. You know, it can handle shocks really well, but they don't degrade, because hydraulic fluid and all that is, you know, usually going to be really fast moving, but then when it's extruded with the right bumps and grooves and channels, you create a degree of boundary layer cavitation that will improve its speed and velocity in certain areas, and those experience a decent amount of heat and pressure, but not as much as you expect. Yeah, so it improves fluid flow. And, well, I mean, the right hydraulic fluid needs to be used, because it'll degrade if it sits over time. But we already have hydraulic fluid lines that don't degrade, if you don't know, that are hoses, which is just kind of like an upgrade to that. So, as a result, it's like, suck it! I improved your design. Suck it! Because I am all about improvements, which is just extruding the right way with crimping. Yeah, literally, that's what that is. It crimps and it extrudes it over a certain distance, so that way it gives you that effect. And then it's an in to outward approach with a kind of like, you know, Star Trek or the Millennium Falcon's not a bad way to put it, truthfully, for what it's worth. No, because that one's different. It goes from in to out, then it curves it towards the center, and then it curves it towards the rear. But it has some that's coming out the wrong way, and the majority of it's going the right way. And so like that then has to be curved up into the flow, and so it takes the circuitous route into that, but it's designed with the pressure in mind to combine it into one singular continuous flow, which is good, you know, but then that goes off into your turbine, which has like all the rest of that going on. Yeah, right, it's to capture its energy. Yeah, so it's like, well, that's a lot of work and nobody makes this, so that's all brand new. Yep. And it goes way faster and harder with way fewer degrees of dying, which is nice. And here's my cool, you know, design for, there are 30, okay, so there's 23, 30, and 33. Those are the three sizes of tires for motorcycle. They're wide, they got a big, solid 3-inch sidewall, you know. They have a good tread, you can put whatever tread you want on them. I personally have like, this kind of, it doesn't matter. Point is, tread's not that important. Alright, and the rim is a arched bow kind of like thing, but it's teardrop shaped. And there's two of them, with little teardrop stators in between connecting that. So that way it can bend a little, but not much. And that way it's very aerodynamically efficient going through the air, which is nice. You want that. And then brakes I have also as a design. They're clamp styles, so two clamping in the center, which is the rotating part. They have a let's see here, material designed with ceramic that makes a electromagnetic. So they're regenerative, but then they can be used as regular brakes. But that heat has piezoelectrics, so that way, like as it happens to cool off, because they're drilled and slotted in such a way with a housing around them that pulls air in a very specific manner into, that the kind of like directed stream of your travel path, meaning it takes a little bit of the air from the front and it sucks it and then it pushes it off to the side, but then in the flow of your motorcycle, so that way you don't have as much resistance to traveling faster, which typically I think people like that. I don't know, but someone says to me that they want to go faster, it's like, well, that's a way to not have that be a problem. So anyways, it helps cooling, helps regeneration, and then you can still get a lot out of them in terms of longevity, life. So that's a great design. It also happens to need to push it off to the side and diffuse it with like air, and so I tend to suck it from the side in that kind of aspect. So it's like I'll suck it a little bit from the front and then a little bit off to the side as it trails off, and that produces a lower pressure zone that's typically right in front of where the bike is anyways, from the wheel being there. So like it tries to help that turn into something that helps the brakes cool off faster, which is good. Same thing with the rear kind of thing, which is nice. And then I was like, right, and then why don't go all out with hyper-eutectic, small aluminum, and then ceramic arch bow thingy sheets that have like sodium ion batteries in the center. And then I was like, shock and spring? Well, I'm already cooling shock and spring, so like I'll put hydraulic fluid and then pressurized air and cool that area with a thermal siphon kind of thing as it comes out into the tube, and that can be even lighter and stronger. And then I have these big, they're not meant to be very wide, and so like they're 5 inches wide, but then they have the 3-inch sidewall, and then they're 23, 30, and 33 inches in diameter, because it works very well with the axle transmission that we have with the gears. They're very resonant, meaning they have a very good degree of efficiency off of those sizes. And as a result, it's much more easy to travel down the road. So, that's nice. It's a brand new, totally bespoke design. Yes. The front is also a version of 2 shocks, 2 curved, like your forearm, has like a tibia in it. It has 2 bones that are curved towards the wrist pin. Kind of the same design for the front, where it's slightly raked forward, but not super raked forward, because I want you to be able to lean forward, but I also want you to be able to sit back. And then same thing with the seat. It's a fairly wide seat that has like kind of a spring to it, but then the rear part has a kind of like a trailing off, sort of like what they do for pitchers or carafes or whatever. But then like that gives you like up to your past middle back, so it's like it'll give you nice arch support, and you can lean back pretty nice. But like that stiffens like the plate ceramic in the center of it that has cushiony and then string, effectively, kind of like a nylon, but it's not. It's another synthetic fiber with padding around it that then uses this as a base, and then several connecting spots that have, again, springs, right? Good old leaf springs and some shocks. Hey, works out. And then that allows for it to be very comfortable riding with a good kind of, solid seating position. It's kind of like a cruiser, but then you can lean forward and it'll bend forward along the sides, and then you can hug it with your legs a little more and lean down like a cafe racer. And so like you got big front, but they're the same size. It's not like American Chopper where you get a big old wide fat rear. Same size, but then you have front and rear pushing and pulling you. And it's meant to squat, but the way it squats, it goes because it's as things load with the engine. It has to move fluid down. A good way to put this is it loads the front, tilts it forward, and then it levels it out and it goes slightly to the rear. And it'll load up the rear a little bit. So the front will get loaded first and you'll lean forward a little, and then it'll level out down, meaning it'll go move down and squat, and then it'll slightly load up the rear as the front will come up. And like that, it's designed for the spring shock system. As it moves the fluid and the spring pressure around in its frame alongside of the different connecting wrist pin areas to make that occur. So it's stiffer in other areas and softer in other areas, and then it will completely stiffen and then load up mostly the rear. This has to rotate it forward, which is a tube fluid design. Pressure can move. How does that work? I don't understand anything. Nah, none of that happens. And I'm like, well, it does. It's valving, effectively. I know. It's like this thing's going to spin. That then is connected to things that then get pressurized and change their valve spring rate, which then allows for fluid to flow, and then also pressurizes other areas, and then that makes it so it dips lower here, and then levels out, and then it gets stiffer in rear, and front becomes less loaded as it goes to the rear. Yeah, as acceleration still is also helped with the multiple gears. Many multiple gears that effectively mean there's no fucking way it's going up. Especially with turbines, which aren't gonna fucking load it like that. Yeah. So it's like, really go fast. I want you to really feel the speed. Really launch. And I was like, oh, I can probably hit around 9G if I want to. And then I did. I just had to have the right turbine, which is a different turbine. It's a bigger turbine, if I'm being honest. This one was meant for bikes, which were never even really kind of supposed to go towards 60 miles an hour, let alone that fucking top speed, which was like near the 500 mark. So it was like, yeah, no, I don't know if I want to ever ride that. But that's effectively all that really was. Which was nice. First sip of coffee at 6:51 p.m. Hells yeah, this is not going to be good for me. It's a strong cup too. I should have really only done one scoop. That would have been a good idea. The Gaff Phaser. I swear, they were the worst at making background noises. People probably hate those background noises and didn't want to listen. They're so mean to me, I swear. And the cat, you go after the cat all the time. I keep telling you not to do it, and then I encourage you and all that fucking shit. With the negative and positive reinforcement combined. I used to go outside more. I'm having trouble with my feet and pain in my entire body. So it's a whole thing, especially when it's like, well, you're going to suddenly walk like 10, 15 miles. And it's like, I didn't plan on this. So that's nice. So, anyways, you're gonna hear slurping sounds. If you can't handle slurping sounds, well, that sucks for you, I guess. Deal with slurping. You don't have to slurp. Slurping makes tastier. Yeah, Phaser. I missed you too. Yeah. Although, we're always next to each other, so I don't really see what the difference is between that moment and this moment. But, you're a dog, so, that's what that is sometimes. Oh, you're right. You need water. Let me get you some water. Let's help you with some water. Anyways, that's the whole point of the concept of, turning, an upgrade pathway, but then it was this is just a fucking goddamn motorcycle. What upgrade? What upgrade is that? And I had to conclude that was completely correct in every way. But I was I was a business that was just, these are just parts that I make. You know what I mean? I make upgrade parts for engines. I make upgrade parts for, and then these turbines are really the only turbines, but then they're jet engines, depending on how you do it. Give me a second here. Because it was right, well, I could sell it to you for $10K, this jet engine, but you need to order 1.5 million units. You'll be the one that takes care of shipping and handling, but we'll quality control up to 10 of those units for every 4, because we're going to do it in 4 stages for all of those units. You get 10 of them for each one of the stages, because it costs a decent amount to produce. We'll replace completely for free, but we don't insure anything other than we're going to put it in this housing. You can put it in pieces, you can assemble it yourself, or we'll put it in this thing fully assembled, and you can put anything else around that. But for sure, we know that that's good for a 10-foot drop, and pretty decent acceleration, deceleration stuff. That kind of thing. But not something where you roll over or massive, impact occurs. Stuff like this, Right. And should it end up being during shipping that something came out of whack, we'll replace it if you want to. Or if none of that occurred and it was just really bad, even though we do quality control, to that point, all the way up to reassemble it or put it in the pieces after assembly, or we put it in the box with the assembly. So it's we run that quality control, but you're going to have to do your own quality control there. We don't do that. We certainly don't assemble it for you. We are not going to install it. We're not going to do anything. These are your engines to do with what you want, and because they are not the standard turbine jet engines, you don't need a license to buy them. And for $10K, with the amount of power that they produce, it was a really attractive offer, let me tell you, for a lot of people. Our whole shtick in my mind for these fantasy and everything else was the vast majority of the time we were an upgrade pathway for standard existing planes, trains, boats, and automobiles, So cargo ships became, for boats or in terms of planes, far more viable because they use a lot less fuel, because one of these big boy turbines, which can be turned into a jet engine and placed in the right area of a existing huge, and I mean big, think B-52 style size, humongo, even bigger, could be replaced with one of these singular engines, and it would outperform it in terms of the amount of fuel used and the total weight that was there, especially with the weight being in the right optimal areas during use of the aircraft with higher altitude, which makes it more efficient, especially since you're bigger. So, that tends to help too. Then there were upgrade packages for the wings, where the wings are technically like bifurcated in a way, where they have the leading edge separated into two halves with a center that bifurcates them and then sends them off into the engine area to have intake, where the bottom will allow for a stalling effect. God damn it, phaser. Meaning rotating vortex inducers and some proper fullering and dimpling in that area. Phaser, could you just give me a second? Jeez, you want to bite at me every time I sit down. He's got a little sheepdog in him or something like that. Anyways, that allows for that to, with the top part of the wing also being an intake to the engine in the rear, or engines if you wanted multiple. Phaser, no. Alright. That would improve its efficiency for lift, especially in higher altitudes with larger wings and a greater degree of plenum volume and a very significant amount of compression, especially since they're these little whale bumps. So if you look at a whale fin, they'll have little bumps on the fin. Well, if you do the right channeling and the right size bumps with the right angles, and they can extend forward as different air velocities are there, you then allow for that stall effect to suck in air and have a rotating, well, it's not really rotating, it's more of a vacuum area that essentially creates, lift, like we say, but it still has air that comes around just, above it, but it's a very low and very high pressure environment for the wing size, improving its lift characteristics and also at higher velocities its flow characteristics and its lighter weight. But the big deal is that it needs hydraulic fluid in certain areas with the correct stiffening geometric shapes to improve as it changes its shape and design to improve its lift and velocity characteristics at the given altitudes it's going to go at. Which is why one big boy style turbine, turboprops sort of thing, which is also ram air because it's the freaking leading edge of the wing, and then that's a vortex that's no longer there because that's going to be channeled air into that little air intake, which then wraps that off into the big boy turboprop jet engine thing, which improves its efficiency dramatically and the fuel use significantly. It's not dramatic, it's just significant. Dramatic is like, what the fuck? Significant is like, damn, I like that. You know what I mean? There's a certain percentage once it turns into like, what the, I don't believe it. You know what I mean? That kind of thing. Yeah. That sort of stuff. So it's like, no, it improves its also, handling too, for what it's worth. Because now you have a big old wing that's just there to turn, with much greater degrees of lift and angle that it can gain as a result of that. Because there's no longer a big engine on it that you have to turn or anything. It's in the center. You know what I mean? So it makes it more efficient to have air travel occur for these very big, huge shipments of large weights of whatever the things are that they're shipping. I never gave a shit. That was just our upgrade stuff. You pay for us to upgrade it. We don't ask. You don't need to tell us anything. You don't need to give us any kind of clue. We're just there to upgrade that. Alright, that's it. Same thing with I can always put engines on the tips of the wings, and I can always put in multiple packs and have multiples run, and you get the picture for a massive space plane now for improved lift. And if I have the right amount of storage, because it's if I don't have to burn all that fuel and I'm going to filter some of that nitrogen and I'll combine it with some oxygen, I have nitric oxides and explosive decompressing gases like hydrogen or hydrazine, but it's like that's also a large amount of oxygen, which means with the ram air and some of the degree of heat and pressure. Anyways, point is, there's the right filters, the right materials, blah 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 blah. I get hydrogen peroxides, nitrogen dioxides, and nitric oxides that I can then use as a combiner, meaning they are exothermically reactive together in outer space. Which then turns it into, well, it's a huge space plane with extra fuel at the top end that normally wouldn't be there and you wouldn't want because that's weight. But actually now it's like, well, no, I'm in space, so I want that. I could start with lower degrees of fuel. Now I have to have the right amount of fuel to be able to make that occur, but I have the degree of thrust and I have a degree of lift that with the right velocity, it means that because I made that fuel and I still have some fuel left, I'm then able to increase and have an orbit and deorbit and then have a thrust characteristic that allows for me to still land safely. So it's a space plane that's huge. Big space plane. That's much lighter for its given lift and thrust characteristics, which is the reason why I did it. Because I like space planes, and I want us to go to space, and I think that's a good thing. Anyways, that was why I was like, well, for one of them, I can get a massive increased profit because I use less fuel, and I gained more lift, and I gained higher altitude and higher speed characteristics with the same reduction of fuel. And so you get it, yeah, no, because it's just one of those things where it's like, well, I basically improved everything. Why wouldn't I do that? And it's like, well, it's expensive. So one plane is decently expensive to do. Like it's only for the big boy ones, they start at 30K. You know, for the engine, they start at 30K. And then, you know, putting all that together for the upgrade package of your wing, and then we have to do all of that for our employees, but also machines and everything, then that's its own overhead. It takes its time. You know, but for what it's worth, it's fine because, oh, I gained back that profit, I put it into this, why wouldn't I do it all? You know what I mean? And it's like, well, $10,000 at the big boy, you know, size engine, right? At 1.5 million units is 15 billion. It's 15 billion with a B. So it's like, that's great. Who used that? And it's like, well, they're their own, you know, airplane or something company. They're, whatever it was, I don't know. But it was like, for that kind of, you know, volume, it's like, of course, we're going to basically go to, because they have to tell us that they're doing that. So to get that, okay, done at that price, we're barely making a profit to ultimately our manufacturing electricity, you know, our staff, and then same thing with, you know, putting on hold other people's, turbines and other projects. So we're no longer making anything else, and we'll still sell whatever else, and we usually take care of shipping and handling. We usually take care of all of that. Okay, so you don't have to fucking deal with that. Like that's the thing, and it's like, so you ahead of time told us you want this, then you were willing to go for sure no matter what this, and these are the afforded assurances. Okay, and we will replace up to 40 total, which, by the way, at 10K, basically leaves nothing. It's real close. Right, and so it's like we pay us our salaries, all the electricity costs, all the material, resource, there's a lot of costs. So it's like, as efficient as we are, that's a lot of cost, you know, which then turned it into like, well, you know, so you gave us the time, you gave us all the everything, but it's you pay us ahead of time for the first chunk, and then you pay us ahead of time for the second chunk, but you're, so long as, God damn it, Phaser. As long as you do the necessary work, because we will not, this is the big thing. It's like the contract is basically you are paying that 15 billion, no matter what, even if you say that you don't want the rest. So that's the and it doesn't matter if there was more than 40 that you believe, because we really stand by our product here. You know, like, we're testing all the way. You know, there's quality control in every single one of those damn units. See what I'm saying? So it's like, well, the shipping is the big issue, and it's like you have to take care of that. Normally we would do that, but that's why that's so cheap. So if they're already someone that has shipping or something, or they're willing to do that, and they can get it cheaper, whatever it is, that makes sense for them. And it made sense for them. So it's like, yeah, of course I would do that. Yeah. And it's like, okay, all right, well, there you go. But again, they got it with no problem. We didn't have any gaffes, any goofs, or anything else. You know, for 1.5 million units, that's astoundingly good quality control. Right. But they also have different packages that they can buy, which is turbine or jet engine. They went with jet engine because it's exhaust. And I'm not going to get into any other specifics, but that's what that is. Right. And it's like, we've also had people spend $30K for a big boy engine. And it was like, why? Are you sure? Because we have all of that stuff, by the way. Like, are you sure you want to buy this? What, you know, like, because this is what we typically see them for. They got the pictures, we got the, you know, the specifications, everything. You know, down in terms of its functions. You know, like in terms of outright power, performance, all this stuff. Which is why it's like, are you sure? And then they come over, we didn't need this size. And I'm like, you suck. Just a little. But again, you bought it, and you don't really get to return it. That's the big caveat to us. Like, you don't get to return the thing. It's like, I don't like that. And it's like, well, yeah, I know, I can get that. But there's a reason for it. You know what I mean? Like, if you can effectively pay for that and get the shipping and everything else that you know what I mean? It's like, it's a lot. It's a lot. And you went through multiple, you know, are you sure's, along with definite, should have read contracts before purchasing. And it's a website with people that you can call. They're in live chat. All of that is there. So it's like, you did that. You did that. We didn't do that. That's yours now. You signed away the ability to return it. You signed that. That's what that is. Which is kind of illegal, for what it's worth. But it depends on if you're willing to accept that. Like, there are some loopholes there that can be done that basically mean you can't return it. You can try to sue us, but that's going to cost a lot more than the $30K. And I'm like, just fucking have a ginormous turbine or something. I don't know. What do you want from me? Why did you build, you know what I mean? Why did you make the purchase of the ginormous one? It's a huge one. It's for fucking ginormous cargo ships. It even says that. Like, come on. Which the smaller ones are, of course, much cheaper. Like, the middle is a solid 5, and then the smallest is a 1K, which is enough to run big boy semi-trucks. So it's like, are you sure you need that power? This is really probably not for your vehicle. All right, like, those are things that are there. We only have one small engine. That's it. They're just technically, like, we have two of them that we actually build. Everything else is parts, blocks, stamped, heads, exhaust manifolds, so on and so forth, right? That's what we're doing. All right, but these are small. There's an opposed piston, single cylinder, inside and outside combustion. That's hydraulically fluid in terms of its design for a crankshaft, and it's built for tiny little motorcycles because it can go with a injector throttle. Screw it. It's a rocket engine injector, effectively. It's literally, it's like it sprays fuel constantly at a certain pressure with pressurized air that then mixes and effectively plasmifies the air and the fuel, and then it combines and then sprays out at an incredibly high velocity into the chamber. And it's like, that produces thrust on the head, right? Well, I mean, it's a ring style for what it's worth. So it's a single cylinder inside and outside. So we have valves on there for exhaust and intake. But it's meant to be like, that's a one stroke now. We're no longer two stroking, we're one stroking. Very clean, extraordinarily well burnt fuel. And that increases and improves the pressure. But it's like, I maintain 500 foot-pounds of torque for 49. It's a 49cc engine. That's 500 foot-pounds of torque and 25 to 50,000 RPM, depending on your mode for the ECU. That has the ram air intake and everything else that improves its PSI value and everything. And then it has a two-stroke mode, which is not using the injector like that anymore. It just uses bang juice and timing. You know what I mean? The timing stroke and regular air fuel mixing in the cylinder, and then a four-stroke, which still gets you up to 130 horsepower and quite a lot of torque. Like, solidly in the 100 to 200, depending on your given PSI values for the compressor, which is the reason why it's like, it's not really for regular people. Are you sure you want this? And then we sell the bike frame, but you have to assemble it. It comes pre-assembled somewhat, meaning like you don't have to weld any or bolt or latch or any of that. And then it's fully disassembled, which is quite cheap. But that motor, that engine, okay, is 1K with the ECU and the compressor and all this other stuff for 49cc. Like, get out, right? But it's like, yes, that is what it is. It is exactly 1K for all that. But you don't get the frame. You don't get any of that. That's another 1K. With the frame, you want both wheels, that's another 1K. You want the turbines for the front and rear, that's 1K. Want the hoses? Well, it comes with the hoses, so that's good. Want the seat? Comes with the seat for the frame. You have to assemble it. Not pre-assembled. But you don't have to do any real welding. For what it's worth, you can do welding in certain areas if that's the choice that you want to make. Okay? And then we have small, like for like a mini bike, like a child, to then extra super large, which is XXX large, which is like a 9-foot long bike. And I don't know who's going to buy that, but like that's a thing for someone. No one's ever bought it, to be fair, though. Literally no one's ever bought it. But, like, and then you have, like, different sizes and different rakes and so on. Which is why it's like, well, I guess, okay, whatever, It's like, it's not really what we're really known for, you know what I mean? Like, we have the world's most powerful single-stroke, dual-stroke, four-stroke, adaptable, all this fucking shit, single-cylinder engine, 49cc engine, that the likes of which never will be seen, blah, blah, and I think the engineering, marketing speak kind of stuff, right? And then we have the turbine, which comes only in the one size, which is more efficient, and then it's a bunch of turbine, and so it's meant for this, but it's the size of a standard big block. style inline four for motorcycles. Now, that's because of the turbine and the intake manifold and exhaust manifold and all the rest of it. And so the actual turbine that produces the compression and everything is relatively small. It's only one small part, you know what I mean? It's kind of like the front. That's all you get. That's the power producer, but then you capture the vast majority of power by the time it comes out. And that's why it's big and bulky. Also, the problem is that sucker could easily run you any car at all, because it can easily produce well in excess of 1,000 horsepower if you do it right. But it's really meant for like 500 with 750 foot-pounds of torque. So it's meant for people that want that. Like, they want that kind of style of extremeness that is provided. You know, like, it will immediately give you all of the power and torque that you're looking for at any given speed. Launching is stupid, but you're not going to flip. But it's really, again, lots of warnings. They're signing any waiver rights. Basically, like, if you hurt yourself building this or, like, writing it, it's not our fault. You died, I don't care, you can't sue us. Like, literally, that's what that is. It's essentially, we know what it is. It's a really stupidly powerful engine. It's a really stupidly powerful engine. And same thing with the single cylinder, version 2. It's a really stupidly powerful little tiny 49cc engine, which means you don't need a motorcycle license to ride your motorcycle. Same thing with the turbine. You don't need a turbine license or a jet engine license to freaking buy it. So we were like, on the safe side, erring for caution here, we don't want you to be able to fucking go after us law-wise, legally-wise, in any capacity. And that's what that was. Because that makes sense. You know what I mean? You kind of have to do that. And that's just a bunch of contracts and waiving rights away and everything, which is stating that you do understand, fully did read, and blah, 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 blah. Lawyers got involved. So that made sense for me to do, because it's like, well, that's a really simplistic way of getting around some of the problems, especially since the engine's sold separately. You can put whatever you want in it. You can mount whatever you want to it, basically, as long as it'll fit. And the engine cradle can be differently sized for what it's worth. But then it's like, I don't have a really tiny, lightweight as hell, 49cc engine that sounds amazing, like a four-stroker. That's 1 and then 2 going off, and then 1 and then 2 going off, and then 1 and 2 going off all the time into the turbine. So it comes with a turbine that adds its power to everything, and it helps with the rest of everything else for its compressor and pumps and so on. So it's like, it's a really, really powerful, efficient platform. But you said 50K, and it's like, well, that's because it's basically a forged piece. Yeah, and then it's a hydraulic ram technology for a crankshaft, which is like, that has to have it come back in, and it goes also to push it up. Well, the inside and outside is also their own version of combustion. Right, and they can two-stroke that, or it can single-stroke that. So it's like, on the pull in, that also adds a fluid pump to it. And it's about how it wraps it around the 3 tubes that are there. It's 3 tubes. Literally, that's all it is. It's a steel chromoly on the center, which has to be the right thickness. It has to have all this other stuff going on. Alright, and then the outside, which helps with the oil and hydraulic fluid, because you have to lubricate, which is mostly just hydraulic fluid. The oils as a pressure for the valves, right? And it acts like an insulator, and it changes depending on where it pushes it to. It's set up for single stroke, dual stroke, or 4-stroke, quad stroke. Right, and then there's the pressure, and then the ring, and then blah 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 blah. So it's like there's a lot going on with it. But and then I have the spinning turbines at the top and rear, and then intake along the side and exhaust along the side. And then I have the front turbines that send it to the front, the top and rear, or top and bottom really, for the given, fluid flow, hydraulic fluid to the axles, which are nice, you know what I mean? That's also why they counter-rotate, so that way there's no torque problems, and the oscillation is canceled out, primary balancing is canceled out, because it's oscillating together in opposing ways, so towards the center and then away, and then towards the center and then away, and towards the center and away, right? Oh, yeah, and then same thing with the spinny discs of turbines tends to help it a little, be a little bit more efficient, which is a good thing, and so it's a very smooth operator, so to speak. You still got your super turbo, still got all of that, and it's a ridiculous amount of torque that's maintained in one stroke, which is why one stroke is not really something we recommend for practically anyone. It's basically a rocket exhaust that we shove into the thing. Because that one's its own thing, where it's like at bottom dead center, outside dead center, that's when it exhausts, and then that goes actually into the outside, which then actually helps with its own degree of maintenance of torque, as we keep pressing it as high as we can, really, until it eventually goes into the turbine, which then still gives it to, like, the hydraulic fluid flow. So, that's its own, like, super hardcore, really well balanced, extraordinarily high efficiency, powerful 49cc engine that would never really be viable for anyone else that looks at any other 49cc engine, because they don't have the tech that I have. That's why it does the 500 fucking foot-pounds of torque and 50k RPM up to, and a stupid set of gears that are almost like a CVT turbine torque converter set, which means like you're not going to die doing anything, but then you could very quickly. So that's the point. It's like, well, this is stupid, but I wanted to max out every bit of performance and efficiency, because like I'm that kind of person. Like I'm literally like, that's my mind. My mind goes after that. So I was like, wow, I really wanted to make this super, super hardcore and basically make a whole bunch of idiots. They're not, though. Not know things and definitely be totally disbelieving in all the ways that it could ever be done, and ignore it because that's insane and it couldn't possibly. And I knowingly look at you and smile, knowing full well I am definitely intelligent and know that this works. And I look at them waiting to see if they'll be curious enough to try it. Just stupid enough to really get themselves hurt at that point. It's like, oh yeah, let's see if they'll ding ding ding. Oh, are you making that over there? Next thing you know, it's like, look at me and my quad stroke freaking single cylinder opposed piston, which still 49cc. Yeah, that's the thing. Like, it's still 49cc. They only count it for bore and stroke, which means I have a loophole. Same thing with the turbine, which is like, it's not a turbine. You know what I mean? Yeah. Which is such a cop-out in a lot of ways for some, but it's like, yes, but at the same time, it's not. So I don't need a license. And I can get that one through pretty easily. It's like, that's what it is, but it's like, oh yeah, here you go. Here's an ultra lightweight frame that's also a hybrid, Yeah, that's super stiff and well balanced. Mm. Really strong, very comfortable ride. And then I still have like the axle housing, which is the static charge and electromagnetic flux motor. So it's an axle, kind of radial style as well. Motor for the turbine versus the axle housing. So it's like that's also why the batteries are there. It also helps with some of the electromagnetic, or not electromagnetic, static charge and plasmification of some of the fuels, which is really, really good. As an increaser in terms of outright performance. So it's like really strong materials are used here with really strong hard ceramics and really strong geometric shit. Like lots of really strong shit. All just to make it so it doesn't die. And will last for very long, enormously long amounts of time. So that's also like why I don't get a lot of actual orders for it. For one thing, I don't market it very well. I don't market like that whole fantasy of mine. It's more of a word of mouth, because it's like, well, no, I have the money. I have the licenses to manufacture, and it's all within the specs of California and EPA and all of that. In fact, it's better than any manufacturer, which means I get tax credits and more. So that's nice, but then it's also really kind of a dangerous sort of motorcycle, so we market it as a motorcycle, but it's not, because it's only 49 cc's. It's more like a scooter. I know, and they're like, no, huh? And it's like, yeah, well, it works. And then they're like trying to pass laws. I'm like, boo! Everyone, look at them trying to do things. And they looked at me like, dude, come on. That's the most fucking out of this world dangerous fucking engine. And it was like, come on, though. Don't you want people to learn on a stupid engine that's light as hell? Like literally, it was like, what the fuck are we doing? To a certain point, it's like, what am I doing here? I'm making it so people will absolutely get murdered by something. It's so lightweight, it's so compact, it's so all these things. It's just like kind of just ridiculous after a point, which people want that. It's super high performance, but hey, all told, it's under 10K to make the thing, regardless of the size. And so they're like, well, that's a fairly expensive motorcycle, but when you think about it, is it though? Especially that engine. It's only a $1,000 engine. For what it's worth, I can get the upgrade package to the ultra efficiency. I can run off of like hydrogen. I could really get myself some decent performance here. Do I need 1,000? Oh my god. 3,000 fucking horsepower. 15,000 foot-pounds. I don't need that. And so, it really became much more industrial applications for what it was worth. Because it was like really, really, really difficult to get, certain people to purchase it. They were in the performance area. Because that's kind of what that is. You know what I mean? But it's like, well, for the industrial area, we're doing quite well. And I'm not really marketing it much because we're really just upgrade parts. Like we have engine blocks, and we can put a whole engine together here, but like we sell parts. You know what I mean? Like we only really ever sell turbines, and our expertise of upgrading your given setup. Like hydrofoil package for your big ginormous boat. Here you go. Hey. Hey, you want this massively big space plane cargo ship heading? I don't know what the hell they're shipping, honestly. I really did never. I know that they do like heavy cars or Pinks or something. I'm sure there's them in there, right? Yeah, but it's like I don't know. But if they want it, they have it now. I just never really bothered to look into it. That was never our jam. But for passenger airplanes, it was really easy to convince them because a Boeing 737 now all of a sudden has the ability to run on practically no fuel and get you to Australia easily from northwest Canada or northeast Canada, which is its own what the fuck? And it's yeah, but that's high altitude and very fast velocity with incredible velocity or airflow and efficiencies and lift characteristics. So makes a lot of sense to do that for what it is, because it's I really want this 130K altitude at Mach 5. We're going Mach 5. Whee! Stupid. But it's you do. That's the thing. That's the better lift and the better fuel efficiency at that point. So it's that's what you'll do. So and then we were lifting body characteristics can be achieved too. Let me just get this humpback kind of thing. And we'll have the nice little scoops and fullers and or channels or fluting, whatever you want to call it. And then the right scoops, and then it wraps it towards a teardrop shape, and it creates its own version of a vacuum area as it scoops it down into the engine. But then it also has a very fast flow at the top as a result, and then the stall boundary area is what also gets sucked into the engine, making a lifting body characteristic occur. Along with wings. So it was 130K, this is easy. Boom! And it's just coming out with steam. There's no hydrocarbon use. It's just hydrogen. It's liquid hydrogen, for what it's worth. And there are a necessary amount of sodium-ion batteries, because they're less likely to explode when broken. Same thing with fluid bladders that are very, very difficult to puncture and shear. They could still ultimately do that, but if they did that, then I'm pretty sure you would have pancaked or nosed right into it, almost full force, the ground. So I was that's good enough. You're dead anyways, you're not surviving, get out of here. And then semi-trucks were super easy as a sell. You know what I mean? If you want to buy your own, this engine and you own your own truck, you can make a company just off of the fuel and everything else that you save over 5 years, because you just use hydrogen or some hydrocarbons that you make with a one pot that we also sell. See, we sell small little fuel recycling kind of things for the exhaust, but also for sewage treatment. It's we still have to put it in the sewage. It's yes, no, but we never use it. For what it's worth, it goes into a one pot, which is kind of like a septic, but then we have to bury it, and then we have to go through the whole process, and it's very unlikely. You have to be intentionally trying to damage it to break. So it's oh, and here's some solar panels, which we have our own version of solar panels, which are constructive and destructive interference with certain, night vision goggle compounds where they increase certain photon wavelengths. Okay, which is good, but then we have the right lensing, and then certain. What's a good way to put this? Because it's they're really reflective materials that have the right grooves and slots in them, that have in certain areas the compound that increases that light, and it constructively destructively interferes like a lens the correct wavelength that you absorb for the natural light that's around us, and I make up for some of it, in fact all of it, by having that compound there, but then also constructive and destructive interference from radio wave, microwave, and IR in ultraviolet and gamma, which is pretty rare, but it's there, you know. So, and then we have to use the right materials around that are our photovoltaics, and then we cool it using a three-phase liquid, which is three liquids. One is low pressure, the other is a supercritical liquid, but it's inside of that lower pressure fluid, and then we have a soda bubbling, like a gas inside of that low pressure fluid that stays as little tiny nano-sized bubbles. So when it happens to, expand upon getting hotter, it then expands and it reduces the Leidenfrost effect, and it produces a pumping action to then get cooled and condensed and then put back into the system as it uses the hot side as a pressure side. Now that then goes off into its own version of a waste heat generator, which is a bunch of little micro linear generators that use like another version of this fluid. This fluid is different fluid. This fluid can't be that fluid. Okay? I know, there's conversion problems. I'm like, yeah, I get it, but whatever. I never care. To be fair, I really didn't. There might be, honestly, someone out there that really cares tremendously, but I don't, because I'm going to put like a whole bunch of them together into this one area, which is then going to massively increase this heat for what it is. But this waste heat generator will be talked about. I've already talked about it before, but it's effectively like another reservoir, and then they go and move one side with little holes as it expands from a liquid to a gas. Then we use like a nitronol type of wire that's a memory wire that goes back to shape as it's heated. So it'll be hot on one side and cooling on another, and then eventually that will, bring it back, use that force, and then that kind of thing, or just regular springs. It depends on what you want to do. I never really gave too much of a shit after a certain point, because it's like there's multiple different ways of doing that, and that's kind of like 3D printing, and it's just like, any other radiator reservoir here goes over. These are all little micro channels that then go up to the hollow kind of Weaver style heatsink fin that allows air to pass through it. So it like makes it way easier. But back to the solar panel, it's again material that's underneath that then also uses the liquid gas as a amplifier, quotation marks, to the electron gap. So it's like it reflects and it holds a little bit of that light, and it expresses it into the material that makes it so it'll increase its electron gap potential. It also happens to be, depending on the type of material you use for your solar panel, has too many electrons or too few electrons, which helps drive an electron potentiation into the material for its conductor. But it acts like a catalyst to do that, and then it drains the light that's emitted, because it produces heat, back into the system, and then it cools itself off, because there's still going to be heat. Still going to be heat there. That's kind of the thing. So it's like, it's a very efficient solar panel. It's designed to have those materials that produce the electricity be for the wavelengths that we're looking for. That can be extremely dense, which is usually a lot of heat. So that's why I have a lot of cooling. Which the front part is also its own version of, well, that's kind of like a heatsink in its own way. You know what I mean? Just allow air to run through it. Yeah. Yeah, and so as a result, it's a lot more efficient for what it's worth. Quite a bit more efficient. It lasts pretty long. But by the time it's done, it's like, well, those materials would have degraded just like the night vision, goggle material. So I just didn't really care. You would have just replaced them anyways. Where I was going with that was, it's a way to run with a little bit of algae, which, that's basically along the sides of your fence, and that's just bags that they run, for what it's worth. That's really all they do. So, yeah. Anyways, then you use the one pot method, which is, a multiple series of stages, and so you have to have multiple one pots. As one is going, then you can fill up another, and then that gives you fuel in terms of natural gases, diesels, ethanol, other gasolines, so on, that you can filter and use for your own whatever reasons. And then it spits out that and then processes that using the solar panels and some batteries and wind, okay, to then make a separation of the various elemental or compound, dried significantly at that point, amalgamation powder stuff. It's effectively all it is. It's a bunch of powder. And yeah, I know, it's like, well, that seems stupid. And it's like, well, no, it isn't, and it is. It's like, well, it's going to be your fertilizer. And it'll also be things to make batteries, because, you can turn that into a battery pretty easily. And then you have your own vitamins and minerals that you can shove into the fertilizer. And then you have minerals that you'll take, that you'll want for either batteries and or just as minerals that you can use for anything you so choose, which means irons or other stuff, effectively. And it produces more energy than it takes to run the thing. But that means for a semi-truck driver that has, let's say, a family, and they poop and they pee and they eat food and they throw garbage out and they have plastic that breaks or whatever, they can throw it in and they can get fuels. And they significantly cut their overall energy use, and they get back the carbon, which can be put back into the fertilizer. Or I was hoping to get in touch with government, big brother government, to go, hey, so if they return this, you'll give them a free carbon catch can and, tax break, because that's nice, because, or just straight up money, because it's carbon, and then you can sink it in the ground as carbon rods that you can just sink in the ground. By just drilling a little, and it'll be in the ground now as almost effectively pure carbon. Which means now it's carbon sinking, like significant, heavy carbon sinking, which is a good thing. You kind of want that. You want carbon sinking. So, no more coal, and it's now a recirculating carbon economy and carbon ecosystem that's a part of what we use, and so we can ramp up or decrease as necessary, especially when your trees will take carbon out of the ground, and you have sticks and leaves and grass that you can throw in, and normally it wouldn't be much, but now it's actually going to be recaptured, and the fertilizer will go back in, and the system continues to have higher degrees of efficiency for nutrition for those plants to continue to grow, and they don't degrade as much over time, and a better root system, and therefore less dust, less pollution, less allergies, lots of that stuff, which you do have. Now as a way to carbon sink. They also were like, hey, you know what, here's a 7-piece drill bit that'll go down like a decent distance, and then it was like, right, well, as you go down a certain, it connects to another thing, and it's just a bunch of little electric motors, effectively, that then drills down, and then it's like, well, that's not going to fully take it out, right? So then it turned into like, well, I mean, for what it's worth, I then have it rotate with like these little splines, like the bore machines that they have, huge machines that have those little, circles that crush the rock. And then I have regular drills that are around that, and like slowly over time, it'll crush all of that. Like it drills, and then it's like really thin, and then it vibrates that, and then it moves those little pieces to then try and like drill into that. And like if you go slightly offset as you do it, like you'll slowly be able to get further and further down. And all you have to do is add water every so often, and you can pump that out for what it's worth. And then you have a really deep hole, borehole, that costs a lot less in terms of energy to make and produce. And then here's some carbon, just here's that, and here's all the stuff that we pumped out on top of it. And I guess I'll just throw that in my sewage for the leftover. You know, go eat, yeah, because who cares at that point, you know? So look, I got my carbon sink. That'll be coal at some point, I guess. I don't care. I really didn't. I was like, I'm so done, I don't care. It was literally like, I was so done. There's obviously a way to do this way more efficiently and way better and give you way higher degrees of, output of energy for the given energy used, alongside of carbon recapture at the source, which is going to make it far more efficient. And there's a way to sequester it, doing your own little part. Now, granted, if you don't have a really big or any backyard, then you don't need that. But it's like, for what it's worth, we're talking about the semi-truck guys, and anyone can really do it. And we have different sizes, meaning you can scale, which was why I was like, well, hey there, government, and any possible, private entity, which we basically wrote, well, you only will get this from us if you work together to scale and make sure that the, grocery stores, the Forest Services, and all this other stuff put their stuff in, and it doesn't just go to waste and landfill. And they pay you to take it off their hands. That was the only way to effectively incentivize corporations that mean that we gain efficiency from our design and output. As it scales, you get bigger and bigger amounts, and you can sell fuel so cheaply with incredible octanes or fuel oxidizers that are just fine for our atmosphere, especially with carbon recapture and other, oxide recaptures. So if there's any, let's say potassiums or nitrogens or, other compounds, then they'll go back into the system, and that'll be a good thing. It then ultimately ends up becoming far more efficient to run setups in every county that then give fuel to every person in an area, or have your own to run for your own personal use, that will not blow up and will not be harmful for the environment, so long as you don't intentionally, which has lots of fail-safes, lots of fucking, detectors that'll send it off to all the little, online servers and so on, and be like, hey, you're doing something. You did that thing that says no, don't do that. So we got a report over here that says you're trying to fuck up the environment, you little bitch. Which is the whole reason why I was talking about that, because it's like, well, that's something that's easy. I don't want that, you know what I mean? Like, so basically a bunch of redundancies and fail-safes, and then, a bunch of, if you went through any of that, it's going to detect it, it's going to send that to you as well as other people to make sure it's maintained, with you also being able to do it yourself. But also, should it get far enough, they'll step in and make sure it's not going to have any problems. Which is a big help. You know what I mean? So it's like, yeah, that's good. That's like really a good idea. But now we have a bunch of exothermic reactivity energy dispersed much more evenly, and there's not as much of a monopoly, and the subsidies can basically be used to help curtail bigger, ginormous, systems that are a lot less efficient. Now these are a lot more efficient, and as a result, they're much better to be, used for our needs and for the environment as well. And so that's basically what our thing is. It's like, our business is about producing this shit. Lighter, faster, stronger, meaner, leaner. Oh yeah! You want efficiency, you want power, you want all the carbon and other pollutant captures, and you want to make it so the world is your oyster and you can go anywhere and do anything. Well, here you go. Here you are. It's fine. Go for it and do it. You know what I mean? Like, you're your own person. You still have to be attached to their, because it still produces electricity. If you don't know, like, the system, the sewage system, everything produces electricity for you, along with the electricity that you produce from the solar panel and wind. So it's like, you have more than enough electricity for anyone. Same thing for, like, large, huge, industrial systems, which are now more powered by those bigger generators, and they'll buy most of their power from that, or make it themselves, which basically kind of destroys this idea of needing private entities that are very monopolistic in their area and will sell you incredibly expensive energy. Now it's much more renewable, hybrid for recaptured energy, using sun and wind and geothermal to a degree, depending on the system, right? That allows for a combo to happen. We're still going to use the exothermic of our air, but then we're using the solar and geothermal, which solar is basically also wind. If you didn't know, the wind happens because solar happens. So, like, that's a thing, which is a good thing. But it means we massively increase our overall output while significantly reducing our impact on our environment. And it's more robust. You're less likely to have multiple systems fail. It can always be picked up by a bigger and multiple other smaller and medium-sized sources within an area if something were to fail, which allows for greater degrees of robust redundancy. Less brownouts. Lots of things that are better now. Like, if I was this thing called an island, maybe Hawaii or something, I got this thing where I do that for all the local tourists and all this other stuff that allows for me to gain those efficiencies and gains massive power potential. I can have more people if I build the building correctly, taller, wider, uses the heat and cooling effect of the various people and all the rest of it. So, but it turns into, it's like there's solar panels, there's the right kind of channeling for air to move and cools it off with that heat and gets concentrated, and then it allows for like the whole capture from these, cooling and compressor systems, which help run our AC, but also offset the cost of a pump-driven AC, because then the pump doesn't really need to work for anything other than a big long drop, which is fluid pressure. And then that allows for that to be cooled and then vaporized as it goes up and cools the whole rest of it, which is a thermal siphon, which reduces our overhead cost on our energy demands there, while also making it so their waste turns into fuel, which is more energy captured along with renewables, which is a big improvement. You can put more people in, and it's self-sustaining to a large degree, while not looking garish and ugly, unless you want that. It depends on you, really, truthfully. For me, it's like, well, it looks really cool to me. I like the way it looks for what it's worth. It's like I have like fiber optics. I've got like little, walls that give us very close, and I mean so close you can't tell the difference between the outside and that wall being not a window, but it's effectively it's screened with fiber optics. that give us that kind of effect of a window. And so it's like it's nice, natural, bright, and it still goes with the, so and then that's energy cost. You don't need to increase the amount of light. In fact, you get natural light from that. So you can sustain it better. And more people be willing to sacrifice having a balcony for like still having this window that gives us all the accoutrements, as you want. So it's nice. And you still got the air, and it's nice, cold. It's really good. I like it. It's an upgrade. So like there's that. There's fiber optics. So there's that. And then the concentration of light. We don't want it to reflect, and so like we have absorptive material that allows for that light, which is the fiber optics essentially. For what it's worth. Yeah. And then that helps cool the outside of the building because we have to cool those to make sure they don't get too hot, which is not just white paint, but then we also use that the fluid as it absorbs from the outside, but also the inside as it goes down and then as it goes up. So it's like that's cooling both ways, but you have to make sure as it wicks off into a vapor, it has a path. So it's like that's the big rub for some people. But for me, it's like, that's easy, that's just the right, valves and reservoir areas for like certain pressures and thermal, so that's all that is. It goes off, cools and as it condenses, and then it goes back to cooling everything. And plus it's already colder because there's, air flow from the bottom up, and allows for a continual breeze, which we use filters. Okay, if you don't know, I use filters, so that way people don't get sick as easily from anyone getting sick inside of there, and it keeps the rooms fresh and easy to be inside of in case someone's really, really smelly, you know what I mean? So that's nice. They don't need to be changed as often as you think, but then you should still change them every so often. It's like, what are those? It's carbon and electricity. That's all that is. For what it's worth, yeah. And so, but then water is a tank above. So it's like we use the heat and steam because we want to drain that heat into a water to air, and so like that keeps the heating for water decent. But we want to pump it up there, and so we put it in a lower pressure environment. And then we allow for it to turn into a steam, and then it'll slowly get to the point where it's at the basin, fully, pretty warm for what it's worth, and then that's a battery. So we have a bunch of turbines, one main one, that then disperses all of the water to all the rooms, which gives you those electricities back for what it's worth. It's self-sustaining now. For what it is, it's self-sustaining. You don't have to put electricity into it. You still have to be attached to the grid and sewer system because that's how government works. But, now you don't really use practically anything. It's a water recycler, and you just filter for a given amount of time, and you change out the filter. And then that's minerals that you can use for whatever the hell you want. Yeah. And it's like, well, it's the basin. It's like, what's the size of the basin? It's like, it depends. Like, do you want several floors? Size basin, because I don't want it as a basin that's sitting on top of the roof. I use the floors, the building itself. So that way I gain efficiency and more overall weight that's able to be handled, which means bigger battery. And it's warmed. Could be a pool. Yeah, you'd separate that, I would imagine. For what it's worth, like, I would never probably put that in the same thing. You don't usually want to swim in or drink the water that you swam in. You know what I mean? So, but it can be warm, and that's good design for what it is. You will lose the water though slowly over time. You are going to capture some of the water from saliva and sweat and people drying off from their showers and or escapades out in the ocean. So you get a little bit of that back, and it's going to be filtered anyways. So, It's just a lot of filters. Yeah, well, yeah. Those ones you have to change a little bit more often than air filters. But you change air filters usually pretty often, from what I understand. So, yeah. It's usually just about the same amount of work. So it's self-sufficient. Yeah, there's enough energy from the sewage and the renewables, and the much more efficient design for heating and cooling, and battery that's there, and then all that stuff, which turns it into like you ultimately get like a really high cool see, it's really high tech, it's really cool. This is the new, definitely improved hotel. You want to go to this hotel? This is the only hotel that you really want. This is the hotel. You know what I mean? It's like, I can sell you so hard on this because it's true. And but see, that's the best part, because like the truth is you can sell really well on that, because it's really honestly the better kind of deal. Like, you can sell it cheaper. Like, you basically don't have the same kind of costs that you normally would in terms of the heating and cooling and electricity bills, which is big. Over time that becomes huge, but like, you will be higher tax, so like, you can still equal or slightly undercut, and you can absolutely perform as well as any other hotel, but you have profits that are reasonable, that make sure your employees are paid well and everything else, right? And you also have a lot more guests, because of course they want to know what the newfangled thing is. And so it pays for itself after a certain amount of time, like faster than you would think, especially on off seasons when it's like, well, there's not as many people. Well, basically I'm a generator. For what it's worth, I'm a generator. For what it is, it's a generator. It's like, oh, well, I've got a lot of heat, and I've got a lot of battery power, and it's basically what that is. You have a generator, so that's going to make it so you gain electricity, because the government has to pay you for the electricity that you're putting back in. But then, of course, then the government's going to be angry after a certain point, and then that's its own thing. All right, I got to get going. Bye.